So IE equal to IC plus IB. So IC is alpha IE plus IC B naught. I am taking this equation IC equal to alpha E plus IC B naught. So we know that IE equal to IC plus IB. So I am removing IE and putting IC plus IB. So it becomes IC plus alpha IB plus IC B naught. So alpha IC I am moving this side. So IC minus alpha IC equal to alpha IB plus IC B naught. So IC minus alpha IC can be written as IC 1 minus alpha is equal to alpha IB plus IC B naught. So IC equal to alpha by 1 minus alpha IB plus IC B naught by 1 minus alpha. So this is the expression, final expression for the collector. There are two important characteristics. One it is input characteristics, another one is output characteristics. So input characteristics is the change in the input voltage and current when the output is constant. So here the output voltage is VCB. So we are making the VCB constant and we are varying the input side how the voltage and the current varies. So up to a certain voltage the current is nearly zero. So after that it increases rapidly. So this point is called cut-in voltage. So this is a graph between the input voltage and input current. Input voltage is VBE and input current is IE. So VBE versus IE characteristics is called input characteristics for this particular common base configuration. So IE initially it is very zero. So after a cut-in voltage it will increases rapidly with the VE. So it indicates that the input resistance is very small. So IE not depends upon the output voltage VCB, it depends upon the input voltage. So another characteristic is output characteristic. We are making the input constant and we are changing the output voltage and current. So here look at this diagram. So input current is fixed, IE equal to 0 milliamps, IE equal to 1 milliamps, IE equal to 2 milliamps and so on. Now we are changing the output voltage and the current. Okay. So here it is almost constant. So IC is varying linearly with VBC. So this when you change the VCB output voltage, the output current changes equally during the initial stage when VBC is very small. So as VBC increases to a particular level, IC becomes constant. So IC is constant only. Even though you are increasing the VCB at any voltage, so it is constant from this point. Okay. So this IC is depends upon the IE. So IC is depends upon the IE. It is fixed only. So next we have to find some terminologies. What is input resistance? What is output resistance? So the ratio of change in emitter base voltage V by R is the resistance. So here the input characteristics input voltage by input current. Input voltage is emitter base voltage. Input current is emitter current. So change in emitter base voltage, change in emitter current is called input resistance. Similarly, output collector base voltage, change in collector current is called output resistance. So next configuration is common emitter. Here, what we are doing is we are making the emitter common. So we are changing the angle of the symbol of the transistor. Now emitter is common to base and collector. If we look at the diagram, I have changed the direction of the symbol from this direction to this direction. So here emitter is common to base, emitter is common to collector. Now, as per the principle of transistor, emitter should be always forward biased. Here it is NPN transistor, here PNP transistor. So here N means it should be negative. So collector should be always reverse biased. Here N means here NPN. Here N means so it should be positive. Similarly for PNP. So P means holds. So you have to give positive side. Here you also P, you have to give negative side. So this is the configuration of the common emitter connection or configuration. So emitter should be common between the input and the output. So these are determined by the voltages given at the inputs. Okay. So this diagram shows the emitter, common emitter NPN configuration, and second shows the common emitter PNP configuration. So next one is base current amplification factor. So here also the current is amplified. So in here the input current is base, output current is collector. So here the amplification factor we are using the symbol beta. There we are using alpha. Here we are using the symbol beta. So beta equal to del IC by del IB. Del IC by del IB. So only 5% of emitter current flows to the base. So the amplification will be greater than 20. Usually this range from 20 to 500. This range is from 20 to 500. Now we have to find the relationship between beta and alpha. Beta equal to del IC by del IC. Alpha is equal to del IC by del IC. You know that IE equal to IB plus IC. It is constant. It is universal for all transistors. Then del IE equal to del IB plus del IC. So we are putting a change in IE, change in IB, change in IC. Null change IB, del IB equal to del IE minus del IC. Del IB equal to del IE minus del IC. Now, what we are doing is beta, you know, from the first equation. So we have found del IC by del IB. From this alpha, we know del IC by del IE. From this equation, I am found del IE equal to del IB plus del IC. Now I have to find del IB, which is equal to del IE minus del IC. Now I am using the formula beta. So del IC, instead of del IB, I am using this equation, del IE minus del IC. Del IE minus del IC. Now I am dividing all the variables by del IE. Del IC by del IE, del IE by del IE, minus del IC by del IE. Del IC by del IE is alpha. This is 1, this is alpha. So alpha by 1 minus alpha. So this is the expression for the relationship between beta and alpha. Next, we have to find the collector current in common emitter configuration. So IC equal to del IE by IC B naught. This is the earlier formula. So IE equal to IB plus IC. So instead of IC, I am putting IB equal to del IE by IC B naught. So I am moving the IE in one side, 1 minus alpha IB plus IC B naught. So IE equal to IB by 1 minus alpha by IC B naught by 1 minus alpha. IE equal to beta plus 1 beta plus beta plus 1 IC B naught. So now we have to find the input and output characteristics. Here the input is emitter base voltage and the base current. Base current is the input, not the emitter current. The base is the input. So VB versus IA it is. So IB increases rapidly with VBE. when the input resistance is very small. So it is almost independent of VCE. So VBE versus IB categories, we are calling as input categories. We are making the output voltage constant. So IBE increases rapidly with VBE after the cut-in voltage. So it means the resistance is very small. So IE is almost independent of the VCE. Similarly, output categories, we have to find the output voltage VCE and the output current I. So VCE versus IC categories is known as output categories. It varies linearly with VCE only when VCE is small. As VCE increases, IC becomes constant. So when the low voltage of VCE, it is source variation. Otherwise, IC will be constant when you increase the VCE. Here also you have to find the input resistance, output resistance, so on. So here the current voltage is emitter base voltage to say with the base current. So Ri equal to del VBE by del I. So output resistance is equal to ratio of change of collector emitter voltage to the change of collector emitter current is called output resistance. So del VCE by del IC. So this is all about common emitter configuration. Next one is common collector configuration. Here also. Here the common collector configuration is derived from the factor that collector is common for both input and output. So you look at the diagram, I have round up the symbol by 180 degree. So 180 degree up and first figure shows the common collector in configuration. So if you see the emitter, you can see the collector, you can see the base. The collector is common to base and as well as the emitter. Here the input is base current, output is emitter current. Okay. The current amplification factor. So in common emitter connection, so in common collector, we are using the current amplification factor gamma. So the ratio of change in here the emitter is the output. So ratio of change in emitter current to the change in base current is called common collector configuration. So here common collector, they are not given the input categories and output categories. So here also you have input categories and output categories. So the input voltage is VBC, base voltage. Input current is base current. So output current is emitter current. The output voltage is emitter collector. Emitter collector voltage. Now we have to find the relationship between gamma, alpha, and so on. So we know that gamma is equal to del I by del IB, and alpha equal to del IC by del IB. Now you know the formula E equal to IB plus IC. So in other words, substituting del IB plus del IC, del IB equal to del IE minus del IC. Now gamma is equal to gamma equal to del IE by del IE. So we know that gamma is del IE by del IB. So instead of del IB, we are using del IE minus del IC. So we are using here. After that, we are dividing by del IE through both. So this is del IB by del I, del I by del IE, del IC by del I. So 1 by 1 minus alpha. So in beta, it is alpha by 1 minus alpha. In gamma, it is 1 by 1 minus alpha. Now we have to find the collector current for this configuration. So this is a standard formula, I is equal to alpha E plus IC P naught. So another formula is also constant, IE equal to IB plus IC. Now we are substituting instead of IC, and we are substituting del IE plus IC P naught in the place of which is equal to del IB plus del IE plus. So we are moving the IE in one side. So IE 1 minus alpha equal to IB plus ICB naught. So IE equal to IB divided by 1 minus alpha plus ICB naught by 1 minus alpha. So this is the expression for collector current in common collector configuration. So from this we can find the beta equal to alpha by 1 minus alpha. Gamma is equal to 1 by 1 plus alpha, and beta plus 1 is equal to alpha by 1 minus alpha plus 1, which is equal to 1 by 1 minus alpha, is equal to 1 by 1 minus alpha. So next we have to find a comparison between these three configurations. So when you look at the input resistance, the common base, it is very low. In common emitter, it is also low. In common collector, very high, about 750 kilo. The next one is output resistance. It is very high in common base. It is very low in common collector, and high medium in common emitter. So next we are going to see the voltage gain. So voltage gain is improved by 150 times. So it is a voltage amplifier. So common emitter also voltage increased by 500 times. In common collector, so in the common collector, so it is less than 1. So from this configuration, we can understand that the voltage gain is improved in common base, common emitter. So these both are can be used for voltage amplifier. Common collector can be used for speakers, hoopers, etc. So next one is applications. So application is high frequency application for common base, audio frequency applications for common emitter, and impedance matching. This common collector is used. Current gain less than unity in common base, very high in common emitter, and appreciable in common collector. So what is the application of this transistor? Why we are using transistor? So what is the configuration used in transistor as an amplifier? So out of the three configurations, we are using transistor as an amplifier in tangle circuit. So here the input is a sinusoidal. So we are giving the input to a transistor. It is a NPN transistor. So you need a resistor to stop the limit current. So base current is the input, collector current is the output. So emitter configuration means emitter input and output are summarized connected by the emitter. So the above diagram shows the CE, common emitter amplifier, with the NPN transistor. So the battery VBB is connected with base in order to polarity, base forward bias. So output is taken across the load also. During the positive off cycle, the input positive cycle of the input transistor will conduct. So during positive off cycle, input AC will make the emitter base junction forward bias, more forward biased. So more charge carriers will be produced. So and it is emitted. So this huge current will flow through the load, and we will form the amplified output at the one. During the negative off cycle, the emitter base junction will less forward biased. So less carrier will be emitted. So current also decreases. So the output voltage will decreases. So if the emitter bias is forward bias, you can increase the charge carriers. So if during the negative cycle, the emitter base section is reverse bias or less forward bias means it is reverse bias. So the output voltage will cut off. There will be no voltage if it is reverse bias. If we give a lesser voltage, then it will be output voltage of the transistor will be less when compared to the other products. This is about load line analysis. Question point. So, for any doubt in the configuration, because there are three configurations. Three configurations are important only. So, in this BJT, you have two big questions. Very important question: working of PNP transistor, working of NPN transistor during forward bias and reverse bias. It is one very important question. So next one is this configuration, three configurations. Sometimes they will ask the input characteristics, sometimes they ask output characteristics. They will ask both input and output characteristics. So they will ask any questions. So you have to know what is this configuration, how to connect this, and how it working. So how the graph would be for input characteristics and how the graph would be for output characteristics. So you should know this before writing the exam. If you have any doubt, you can ask me. So we do some problems in rectifier as I already told. Hello? Okay, so shall we move to the problem? If you have any doubts, any no doubts, we move to the problems. So this is all about rectifiers. Disconnected. Sorry. No. 3 lines.
Sir, in the right side also you can draw the chalk piece.
First line, okay, wow.
Now you are. Wait a minute, sir. Wait a minute.
Here,
Left side, sir. Left side.
here,
Left.
one side left.
Okay, sir. Okay, sir. Okay.
Here,
Right side.
here,
Right side. Right side.
here.
Okay.
So first question is about rectifier. A sinusoidal voltage of 15 volts. Voltage of 15 volts, 50 hertz is applied to half-wave rectifier. Is applied to half-wave rectifier. Applied to half-wave. Applied to half-wave. So, half-wave rectifier means you have two diodes only. So they are given load resistor 500 ohm. Load resistor is 500. They have to consider ideal diode. So ideal diode means there is no cut-in voltage. When you give forward bias, so it will conduct. So when you give reverse bias, it won't conduct. That is known as ideal diode. So they have to find out many values. They are asked to find peak voltage, peak current. Next one is average current. Next one is RMS value of current. Next, DC power input, DC power output, DC power output, AC power input, AC power input. Finally, efficiency and ripple factor, AC power output. Rectifier efficiency. Finally, ripple factor. So totally you have to find 7 parameters. So they are applying a voltage of 15 volts, 50 hertz. They are given the input voltage, they are given the 50 hertz frequency. So half-wave rectifier, they are given the load resistor value. They also mentioned that it is a ideal diode. So ideal diode means there is no cut-in voltage or background voltage, etc. So you have to find these 7 parameters. So first one is peak current. So they have given the maximum voltage. First write the given data. So they have given Vm, it is 15 volts. Then F they have given, it is 50 hertz. They have given RL, it is 500. So remaining things not given. So we are first finding the Im. So Im equal to Vm divided by. So Vm is the input voltage. So in a rectifier, there is a load resistor as well as there is a diode resistance. So I have not mentioned the diode resistance. Oh, they have given ideal diode. RF means forward bias resistance 5 ohms. RR, reverse bias resistance is infinity. So during the reverse bias, it will not allow the current to pass. It will not allow the current to pass. So RF is 5 ohms, RR is infinity. So in order to find the current IM, VM divided by RF plus RL. So I have to find the current. So we know the Ohm's law, V by R. So R is not only the RL, so you have to add the forward bias resistance. So VM is 15. So 500 plus 5, why not? So you get a value of 29.7 into 10 power minus 3 amps. Is equal to 29.7 milliamps. Okay. So this is the formula for half-wave rectifier. So this is common only, VM divided by RF plus R. Now we have to find the IDC. So IDC means, so it is direct current. IDC means direct current. So it is also known as average current. So I average, IDC, all are equal. So this can be found only you know the peak current. For half-wave rectifier, it is IM by pi. If it is full-wave rectifier, it is 2 IM by pi. Because we are getting the full cycle. Here only half cycle is applying. So IDC equal to IM by pi. This is equal to 29.7 divided by 3.14, which is equal to 9.45 milliamps. So IRMS, next one is RMS current. This is found by IDC. After finding IDC only, you can find this. IDC by 2. So IM by 2, sorry. IM by 2. Which is equal to 14.85 milliamps. So first I am finding the peak current or maximum current, same only. So voltage divided by forward bias resistance plus load resistance. By finding the maximum current. Next one is average current. Average current or DC current, both are same only. So in half-wave rectifier, the formula is IM by pi. So IM you know that. So pi 3.14, then you substitute, you get the IDC. That is average current. So RMS value is IM by 2 for half-wave rectifier. For full-wave rectifier, the equation will be different. Okay. So this is IM is maximum or peak current. Maximum or peak current. Here average or average current or DC current, that is known as IDC. This is RMS value of current. So if you write it down, we'll go to the next stage. For these formulas, you have to remember for half-wave and full-wave. So IM equal to VM by RL is but the remaining two formulas you have to remember for half-wave and full-wave. Half-wave it is IDC equal to IM by pi. Voice breaking off. So IDC equal to Im by pi. Now, hello, IRMS equal to Im by 2. So IDC equal to Im by pi and IRMS equal to Im by 2. So if you have written this left hand side, I will go to the next step. So we have to find the other 4 parameters. The sinusoidal voltage Im equal to Vm divided by Rf plus RL, IDC equal to Im by pi, IRMS equal to Im by. So from the problem, you write the given data, then you assume whether it is half wave or full wave rectifier. So full wave rectifier means you have to use different formula. So next we have to find the DC power output. So power output means only RL will be there. Diode will not be there. So if it is input means both diode as well as RL resistance. For output we have only RL resistance. For AC power input, sorry, not output, it is input. So rectifier efficiency is nothing but output by input. The ripple factor is how much AC component is present in the final output. That is known as ripple factor. So we want a pure DC output, but some AC component is available in the half-wave rectifier. So how much AC component is available? That is known as ripple factor. So I am rubbing this question. So next one is DC power output. DC power. So either we have to multiply V and I, voltage into current for finding the power, or current square into resistance, I squared R. So here I am using here the I squared R formula. For DC it is IDC, so IDC square into RL. So on the output you have only load resistance. So IDC squared or 9.45 into 10 power minus 3 whole square, RL is 500. So this is the DC power output. So when you multiply this, you get a value of 44.65 milliwatts. Now I have to find the AC power input. AC power input. So AC power input means it is a IRMS. So you have to use the current IRMS square. So here resistance is RS as well as RL. So input side, when you see from the input side, you have to add both RF and RL. So IRMS, you know, it is 14.85 into 10 power minus 3 square. So RF is 5 plus 500. So you get a value of 111.36 milliwatts. Now you have to find the rectifier efficiency. Rectifier efficiency output power PDC by PAC into 100. So 45 4.65 divided by 111.36 into 100. 40%. 40. So one more thing is that. So in the output you have a DC voltage. Rectifier purpose is converting AC to DC. So output is a DC voltage. So we are using a DC current. So I am using the DC current. I squared R is the formula for power. So the current is DC. So IDC squared. So in the output side you have load. So I am using the resistance RL. So I am getting a value of 44.65 milliwatts. So in the input side, so we have to measure the AC current. So AC current, the average AC current is IRMS. So I am using the current IRMS squared RF plus RL because there is a forward bias resistance diode as well as RL. So 5 plus 500 into 14.85 into 10 power minus 3 square. So you get a watts of 111.36 milliwatts. So efficiency equal to PDC by PAC into 100. So you get a efficiency of 40%. So another one is ripple factor. Ripple factor. How to calculate this is, so you have to put a square IRMS by IDC whole square minus 1. So this is the formula for ripple factor. IRMS by IDC whole square minus 1. Then you have to take a square root. So IRMS, we know that it is 14.85 divided by 9.45. Then you have to take the square minus 1. Then you have to take a value. So it may be 1.5 square 2.25 minus 1, it becomes 1.25. And if we take the square root, finally get a value of 1.21. So this is about the half-wave rectifier. So the ripple factor formula is square root of IRMS by IDC whole square minus 1. So IRMS is 14.85, IDC is 9.45, whole square minus 1. So it is 1.21. 1.21. So if you have written this, I will go to the next problem. So I am waiting for your completion. So next problem is about full wave rectifier. So when you go for full wave rectifier, the formula will change. So this time I will ask the answer from you. You take the calculator. So I will ask one by one what is the answer. You have to give the answer. Have you completed? Hello? Hello? So if you
The
completed, I
student,
will.
the students completed,
Okay,
sir.
okay. Okay. So nothing about full wave rectifier. Same thing you have to find, but so there are some changes in the formula because of the full wave. So in the half wave you have only half wave. So in the full wave rectifier you have full wave. So in the full wave rectifier, a signal of 300 volt, voltage is 350 hertz, is given to full wave rectifier. Is given to full wave. So the input is 300 volt. That is VM, full wave rectifier. That is not VRMS, that is VM, maximum voltage. So now RF is 800 ohm. RF is 800 ohm. RR, reverse bias, infinity. Then load is 2000 ohm. Load is 2000 ohm. Now you have to find, as it is the 7, here there is no need to find a ripple factor. Remaining things you have to find out. So you have to find peak, DC, RMS value of current, Then you have to find DC power output, then AC power input, AC power input, AC power input. Then you have to find the efficiency, rectifier efficiency, rectifier. Instead of ripple factor, we can find everything. We can also find the ripple factor by using the same formula. But this average current and RMS value current formula is different when compared to the half wave rectifier. So first one is, so we have to find the, first write the given data. VM 300 volt, then frequency not needed anywhere, then RF 800 ohm, RL 2000 ohm. These are the data they are given. So remaining things we have to find out. So first we have to find the peak value of current. So I max. So Imax equal to Vm divided by both resistance you have to add Rf plus R. So Vm they have given you value of 300 volt. RF is 800, RL is 2000. First, 101 tell what is the value of Im. What is the value of Vm? So voltage is 300, RF is 800, and RL is 2000. So you have to find the Im. Anyone tell what is the value of Im? 300 divided by 2800. So 3 by 28. 3 by 28. So it will 3 by 28. 3 by 28. 0.30 means 1. Then 20 means 0. 200 means 140, 158, 196, 107, 0.107. So 107 milliamps. So this is the maximum current for full wave rectifier. Next, you have to find IDC. So IDC is here 2Im by 5. 2Im by 5. So 2 into 107 divided by 3. Roll number 102, you have to tell the answer. So IRMS, here it is Im by not 2, here it is root 2. So here there is a difference, here it is 2Im by 5, here it is Im by root 2. So Im is 107 divided by root 2 is 1.41. Tell me the answer. What is IDC and what is IRMS? Roll number 102, Dayanand, tell me what is the answer for IDC. I am multiplying 2 with 107 milliamps. So I am finally write milliamps here. So I am not putting into 10 power minus 3. So if you need it can put 107 into 10 power minus 3. Dayanand, tell what is the answer for IDC. Ivan Joseph, tell me the answer for IRMS. Dayanand, speak. If you are not listening, I will put option only. Dayanand.
Number 102.
102.
The 102 is not responding, sir.
104. 105. Ivan Joseph. Ivan Joseph, what is the value of IRMS?
Sir, IRMS is just finding. IDC find it, sir.
IDC you have find it. What is the value?
Sir, 68.15 milliampere.
Okay. Okay. IDC is 68.15 milliamperes. Jabesh Singh, Jabesh, Jabesh Singh.
No, sir.
What is the value for IRMS? You have to divide 107 by 1.414. Take the calculator and tell me quickly. You have to divide 107 by 1.414.
75.67, sir.
75.67. Okay. Now we have to find the power PDC and PAC. Then only we can find the rectifier efficiency. We have to find PDC and PAC. Then only we can find the rectifier efficiency. So PDC formula is same only. So IDC square into RL. PAC is IRMS square into R F plus RL. IDC squared is 68.15 into 10 power minus 3 whole square. RL is 2000. Here it is IRMS 75.67 into 10 power minus 3 whole square into 800 plus 2000. So it is 2800 here. Then only we can find the efficiency n equal to PDC by PAC into 100. Next, Kabilan. Kabilan, tell me what is
Roll
PDC?
number 108.
Sir.
So you find out and tell me what is the value for PDC.
Okay, sir.
So when you squaring 10 power minus 3, it becomes 10 power minus 6. So 68.15 you have to square, then you have to multiply with 2000, then into 10 power minus 6, and find out finally you tell me the answer. Kabilan. So squaring you get a value, this becomes 10 power minus 6 into 2000. So finally you multiply everything and you tell me the answer. Kirtivasan. Kirtivasan. Kirtivasan, are you there? Melvin Thomas.
Sir,
You tell me what is the value of PAC?
sir, PDC போட்டுட்டு இருக்கு சார்.
PDC போட்டுட்டு இருக்கீங்களா? சரி போட்டு சொல்லுங்க.
ஓகே சார்.
கபிலன் போட்டாச்சா? So you have to square the value 68.15 into 68.15. You get some value. So here 10 power minus 6, here 2000. So you can cancel these 3 and you can make 10 power minus 3. கபிலன் இன்னுமா கால்குலேஷன் போடுறீங்க? $68.15 square. What is the value of 68.15 square? You can easily put in a mobile calculator. 68.15 into 68.15. Very simple. It's 4644. So I will multiply by 4 into 2. 2000 I make it 2. So 9288. So this can be written as, again we go inside, it can be written as 9.28 cos 9.28 cos. Similarly, here, 4.6 into 2008. When we have your square root for 2.61 square, it is 5726. It's 57.
Sir,
Yes.
PAC is 15.96, sir.
PAC. It is
Sir.
16 point.
Sir,
96.
15.96, sir. MB.
15.96 watts. Okay. Into 2800. Okay. So you have find the PDC and you have find the PAC. Now you have to find the efficiency. So output is 9.28, input is 15.96. Then you have to multiply by 100. Dayanand, tell me what is the efficiency? So this is a second chance for you. Dayanand, tell me what is the efficiency? So otherwise you will option only. And similarly for Kirtivasan. Just keeping the phone is not attendance. Kirtivasan, tell me what is the efficiency? 9.28 divided by 15.96. Mohammed Ijaz. Mohammed Ijaz. Naveen. So what is the percentage efficiency? You have found out PDC 9.28. You have found out PAC 15.96. Now tell what is the efficiency. So all of you know how to use calculator in mobile phone. So it is a simple numerical number. Efficiency equal to 9.28 divided by 15.96 into 100. So if it doesn't know calculator at all, you can divide this 928 divided by 1596. It cannot be done. So 0 point, you put 0. So how many times it will go? 1600. So 5 times. So 5 into 6, 30, 3, 45, 4, 25, 9, 2, 7, 9, 8, 0. 0, 0, 3, 1, 1, 3, 6, 0, 0, 0. Now once again you put a 0. Now how many times it will go? 5,600 means 6, 9,600, 11,200, 12,800, 8. 8, 6, 48, 4, 72, 7, 44, 12, 2, 9, 3, 9, 7, 2, it becomes 2 only, so 230. So it is 0.58 into 100, so 58%. So if you want to find the ripple factor, you can use the same formula. Ripple factor equal to square root of IRMS by IDC. IRMS is 75.67, yes. IDC whole square minus 1 is equal to 75.67 divided by 68.15 whole square minus 1. First divide this 75.67 by 68.15, then square it and subtract it by minus 1 and take the total square root. So you get the value of ripple factor. Find out. Kirti Vasan, tell me what is the ripple factor? Dayanand, are you there? So I'm first dividing 75.67 with 68.15. 78.67, 75.67 divided by 68.15. So it is 1.11. So 1.11 square minus 1. So 1.11 is into 1.11. It is 1.232. 1.232 minus 1 is equal to 0.232 square root of 0.232. So in my calculator there is no square root. So anyone tell what is the square root of 0.232? Gautam. Gautam.
0.48.
0.4. 0.48. Okay. So in the half rectifier problems, so you may ask Kerry, what is the construction, how it works? It may be half wave rectifier, full wave rectifier, or bridge rectifier. Sometimes they will ask problems also. So you should know the formula then only you can substitute and you can find the values. So this is only about rectifier. So there are problems in Zener diode also. We see in the afternoon. There are problems in transistor also. So transistor problems are two more problems. So Zener diode has some big question. So this is also a big question only because we are finding 7 parameters. So not only studying theory, you have to study the problems also. Sometimes they will ask problems. On that time, you should not blink. I know theory, I doesn't know problem. Like this, you cannot tell. So you should study as well as theory as well as the problems. So in the afternoon class, we see some problems in Zener diode, transistors, and we revise the machines. So in the evening, you have a unit test. It is of 25 marks. So 5 2-mark questions and 2 subdivision big question. In the big question, you have to write only one question. So it is of 15 marks. So it is of AB, like is in CA. 2 questions, 2 subdivisions. So you have to finish within 1 hour, 5 minutes. So I will give, send a question at 7 in the WhatsApp group. I will send the question. So you have to write it down and you have to send me by mail. Send me my mail within 8:15. So within 8:15, 8:30, you have to complete and send me. So 5 2-mark question and 1 big question. So it is all about machines. So all the questions will be in the machines only. It is maybe motor, generator, or transformer, induction motor. So it may be application, problems may be asked, derivation may be asked. So I will revise in the afternoon. So all the students must attend the unit test. So if you are absent, I can put only 0 marks. I will put absent, automatically it becomes 0 marks. So, so everyone should write the test and send me through mail. Is there any doubt in a unit test? So in this class, we have seen what is common base, what is common collector, and what is common emitter configuration, and what is the input and output categories. So in 3 configuration, we see alpha, beta, gamma, current amplification factors. Then we compare this configuration. Then we have seen some problems in rectifiers, how to find the peak value, average value, efficiency, refill factor, etc. So in the afternoon class, we see some problems in Zener diode. So how it is working as a voltage regulator. So how much voltage is needed? If there is no voltage across the Zener diode, it will not act as a voltage regulator. So some current needed to be passed through the voltage regulator. Then it will act as a voltage regulator. If it not so it will come out from the voltage regulator. So there are some problems in transistor also. We see in the afternoon class. So in some of the students who have not responded, 102 and 109, Kirti was. So I will put absent for today.
Absent is 101 and 118.
101 and
118, not joined, sir.
118. Okay.
102, 109 are not responding.
Yes, sir. So if you have any questions, you can ask me. So in the evening, you have a test. You have to write in a paper and you have to take a photo and you have to attach with the mail. So while taking photo, you take clearly. It should be visible. If it is not able to read means I will put it is not able to read. You have to send once again. You can leave the class now. Mohammad Ijaz, are you there?